masterclass. My name is Alex. I'm a co-founder of ShapeDiver and the CTO, and we prepared this masterclass building web apps using ShapeDiver and React to show you to provide you with a great template to build web apps using the ShapeDiver 3D viewer, Grasshopper models running on ShapeDiver, and a really modern web development framework, React, which you for sure have heard of. It's not a simple subject to get started with, but our goal is here to provide a really useful template to create web applications that involve parametric 3D models running in Grasshopper on ShapeDiver and further. As you will see, that this should be a really useful template to get started with React web application development. All right. Maybe it would be good for me to begin with to have a very short overview of your background. Maybe I will call your names one after the other, and you give me like maybe 30-second intro. What's your background? What the experience you have with Grasshopper, maybe ShapeDiver, and whether you have some experience with web development, so I can adapt my speed and my speech to that. All right, let's get started with Parisa.
Yes, yeah, of course. Hello, everybody. I'm from Arcadis, and I'm a BIM specialist manager for Pacific Northwest. I've been in this position for like 3 or 4 years right now, and I really want to learn more. I have experience with Grasshopper and Dynamo, and a little bit of scripting in Revit, and I haven't used ShapeDiver, and I really want to know. Yeah.
Right. Cool.
That's all for me. Thanks.
All right, let's switch to Shang Shao.
Hello, everybody. I'm Shenqiao Yang. I also go by with Jason Yang. So I'm the AI ML engineer in Core Studio. Most of the time, I'm developing the store maps. So recently, we may transfer some store maps to ShapeDiver apps. So that's why I'm interested in ShapeDiver for now. Thank you.
All right, thank you. Next one would be Pinche Lee. Oops. All right, that didn't work. Maybe Jacob Russo.
Hey there, I'm Jacob. I'm a computational designer at SOM in New York, and experience with Grasshopper, Python, and C#, but I'm interested in getting more experience with web-based languages.
Cool, thank you. Samuel. Hi, Samuel, can you hear us? Samuel Winston. All right, maybe later. Let's go on with Shigemura. Shigemura, can you hear us? All right, let's go with Ruud.
Yeah, hi, Ruud. I am a structural engineer. Using Grasshopper quite a lot, and yeah, very interested in the ShapeDiver yeah, the opportunities it gives me to share the script with the Grasshopper experts, let's say.
Right, thank you. Fernando.
Hi.
Hi.
I'm Fernando. I'm from computational designer based in Norway, currently working for Rumble. And I'm very interested in ShapeDiver because I've used it before. And I've seen that there are a lot of possibilities for the things that we do at the office.
Yeah.
So, yeah.
Super, yeah, thank you. All right, next one would be Taro.
Yes, can you hear me?
Yes, we can hear.
I'm Taro Narahara, Associate Professor from NJIT in New Jersey in the United States. I'm teaching architecture and computational design. Have some experience in Grasshopper, but TypeScript, React, I never use. And also ShapeDiver, this is the first time I use it.
Okay, all right. By the way, before we switch to the next one, I invite everyone to actually go to the ShapeDiver platform and register for an account. And then if you want to start a trial, you don't need it for this class because we provide demo models. But if you want to give it a try, don't hesitate. All right, next one is Harsha. Super.
Hello, Alex.
Yeah.
Hi.
Hi.
Hi. Good to see you. Hello. So I'm a computational designer and architect based in London. And we work with a firm called Data Farm Lab, and we are developing a platform called Automata, which helps in offsite construction. And so there are a lot of aspects involved wherein we look into optimization of data and also at the moment developing configurators wherein we are looking forward to work with ShapeDiver and see how it would help us in web-based applications. So yes, looking forward to the same.
Okay, cool. Thank you.
Thank you.
Let's see who is next. Maybe Todd Byron.
Thank you, Alex.
Hi.
I'm Todd Byerther. I'm the product director at Mercer Mass Timber at our factory in Spokane, Washington, and we're using Grasshopper and Rhino inside to drive the APIs of Revit, CADWork, and RFM6 on our modular assemblies, and we'd love to use ShapeDiver on a marketplace.
I see. Cool. Thank you.
Thank you.
I'm slowly losing track who was not there. Maybe Gabriel Florimon.
Hi, yes. So I'm Gabriel Florimon. I work at Corrigan Associates in the United States. I work in the interior studios, but I was previously in education studios, and I'm familiar with Grasshopper and Rhino and scripting. So I'm just excited to learn more about ShapeDiver.
Cool. All right. Thank you. So I make one more pass on the list to see who we might have missed. If someone wants to talk, just unmute your mic and talk. So I'm not sure who did not present himself. Yeah, otherwise I'm just gonna start. All right. Yeah, many thanks for joining. Practical details, my colleague Dimitri is also on the call, who is a front-end developer here at ShapeDiver. Together with Dimitri, we developed this ShapeDiver React example template for a React web app, which is available as a public repo on GitHub. I'm now in the next few minutes give you an introduction to ShapeDiver, how it works in general. At the end of this introduction, we're gonna start working with this repository. So I would ask all of you who want to get their hands dirty to actually clone the GitHub repository using Git, or if you don't know how that works, you can also download this as a zip file. I'm copying the link once more to the chat of this meeting. There is also a joint Slack channel that you can join and ask questions, or ask questions in this meeting chat. In order to get this to work, you will also need some IDE like Visual Studio Code, and you will need to install Node.js, preferably version 18 or 20. It works on Windows or Mac. I'm using Mac here. Yeah, I will explain first steps once we get there. But if you haven't done so, get started with actually cloning or downloading the repository and getting Visual Studio Code and Node.js. All right. So a quick intro to the ShapeDiver and the models we're going to be using here. There is also a Google Drive folder which we've shared. I'm copying the link to the chat once more. Here you will find Grasshopper models some of the Grasshopper models we were using here for the masterclass. You can upload those models yourself once you registered for ShapeDiver on the platform. But you don't need to if you don't want to, because I uploaded those models to a demo account, and the API keys to access these models are available in the repository. I'm picking one of the models here just to begin with, to give you a brief overview of what ShapeDiver is. Maybe I actually show the upload so you see how it works. I'm clicking the upload button here, picking the Grasshopper file, augmented reality cube. Now what happens is the model gets uploaded to our backend system. Our backend system checks that model, reads what kind of parameters are defined by the model, what kind of outputs does the model have, expose everything on an API, and if the check is successful, like right now, I can open the model here in a WebGL view in a model view page on the ShapeDiver platform. I can see its outputs. So here is a mesh with a texture on it that is outputted by that model. From some point of view, it's going to look like a ShapeDiver logo. Here it is, or whatever. And I can see here a parameter panel that exposes the parameters defined by that model. They are nicely grouped. I can edit here settings of how the rendering looks like and whatnot. I'm not going to go into detail about this right now because everything is in the help center and the masterclass focuses on something else. But here you can configure in a detailed way how the rendering looks like and so on. You can also configure here whether you want to allow embedding of the model in web applications, which is important if you want to use your own model for our example. Then you're going to need to allow embedding and allow an embedding domain for local development. In our example, it's most probably going to be this localhost :3000, port 3000. And here you can copy the API key, the ticket, and the API endpoint and put it into the application. As I said before, you don't need to worry about this for this example because I prepared models. I just wanted to show you how this upload works. All right, I'm going to exit this screen now because we don't need it. And I will just show you the uploaded models. Yeah, you can actually explore these models if you follow this link. It's publicly available. I'm putting it into the chat. You can open this link and you will see all the models. You can play around with them. Just very briefly, I want to show you how the corresponding Grasshopper model actually looks like here for this model. You can explore the other models yourself. So here I'm switching to Windows. Can you see my Windows screen? I hope so. All right, so here we see the Rhino viewport, and we see Grasshopper, and just wanted to show you briefly how that model is defined. There's really nothing special about it. For example, this model has some sliders, which show up as sliders in the ShapeDiver model view page. But the model also makes use of some special components that are available in the ShapeDiver plugin, which you can install via the package manager. Right, there's a ShapeDiver plugin available in the package manager. There it is, which you can install easily. And then, for example, using this ShapeDiver plugin, you get special components that allow you to import geometry, to have geometric inputs into the model and geometric outputs that allow you to define how exactly the geometry gets rendered on the in the WebGL viewer and so on. All of this is really well documented. You can find documentation for this if you go to the ShapeDiver Help Center, help.shapediver.com. There's also a link to the Help Center. If you are on the platform here, Help Center, you can go to the support forum to ask questions there. There are video tutorials and so on. All right, that's about it. Getting started with ShapeDiver. Maybe two more words about embedding ShapeDiver models. We offer two ways of embedding ShapeDiver models. One is via an iframe. Embedding via iframe essentially gives you this kind of model view page embedded into another web page, so you get the same UI that you have here. That means you can style it to a certain extent, but not massively. Right? Essentially, this iframe is defined more or less by what you see here, and with a little bit of styling. That's enough for a lot of applications, but for example, you cannot do things like hide and show parameters depending on the state of the configuration. Adding further parameters, showing 2 or 3 models in the same viewport at the same time, these kind of things don't work with the iframe. There's also a so-called direct embedding feature where you simply embed only our 3D viewer into your web application. And then all of the web application can talk to the 3D viewer, call the API of the 3D viewer to change parameters, load multiple models at the same time into the same viewport, do interactions in the viewport, change materials and color of the objects and whatnot. Everything is possible. Essentially, the 3D viewer is very versatile. There is also in our Help Center extensive documentation on the 3D viewer and how to do this. Now, the purpose of what we do today in the masterclass is to show you how you get started, how you can get started easily with developing a web application where you embed the viewer on your own, giving you maximum flexibility about the web application, right? As I said, we have a lot of code examples and documentation here, but still, it's quite a step to get started with developing a web application. So what we did is we created among many other examples, we created an example for getting started with a web application coded in React and loading 1 or more ShapeDiver models and providing you out of the box with a really nice user interface for the parameters, the viewport, and so on. And that's what we're gonna look at today. Before we get started and get the thing running on your machines, I want to show you again this GitHub repo. And you will find a link in the GitHub repo where you can see a deployed version of this example. So this example deployed to a static web hosting location. If you click that link here, then you will see how this sample web application looks like. There's a landing page here which shows you 3 use cases. One is a simple model view page. So this opens a page that shows a single ShapeDiver model, this sideboard model that we have already seen here among the example models. Where is it? Here it is. Here's the sideboard model. You can look at it on the ShapeDiver platform, or you can see it here. Or you can see it here embedded in our web application sample. Now, like in the model view page on the platform, this sample here gives you a viewport and it gives you a parameter control panel. And in this masterclass, we're going to show, we're going to look at how the code of this web page is built, how you can adapt it to your needs, how you can completely change the layout, take some components out, put it in your web application. All of this is quite nicely possible. And yeah, that's what we're going to look at. The parameter control panel that we implemented here, these components, they are very versatile. This control panel can run in different modes with or without change confirmation by the user. Here in the default setting, if I change parameter values, the update doesn't run immediately like on our platform, but the user has to click the accept button to actually trigger the change. Depending on your model and your use case, one or the other might be better, and you can switch between those modes. Nice thing about it is if you can actually see which values you changed, and then you can cancel them individually, or you can cancel the changes completely. There's further parameters in this model where you can change color or material, or the image on the ground plane or whatnot. And we show here a second panel that shows the exports defined by this model. The ShapeDiver plugin for Grasshopper allows you to define exports, file exports, where you can feed in geometry to export geometry, or you can feed in images or PDF documents that you create parametrically inside Grasshopper. And then those documents become available as downloadable files, or they can be sent via email. For example, if I click this OBJ export download button, then actually the export will be triggered for these parameter values, and an OBJ file will get downloaded that contains actually this sideboard as we see it here. There's a lot you can do with exports and imports. I'm not going to talk about it right now because it's all covered in documentation and in the tutorial videos. Yeah. But, yeah, thanks for answering the hot question. All right. The sample that we are looking at, it provides 3 sample pages that all follow the same structure with a header bar and a sidebar and the main content window. But this is just an example. You can easily change that or come up with a complete separate layout, right? So we are right now looking at the view page. There's also a select page where you can pick from one or several Grasshopper models running on ShapeDiver. And the parameter panel shows up here. This is just to show that this parameter panel that we implemented is really super generic. So it's very nice. You can, for example, mix and match several models. The use case of this depends on whatever you want to do. But for example, I could load here this AR cube model, and at the same time the bookshelf, which is kind of crazy because it has a completely different size. but it's possible, right? And then here I get parameter controls for the bookshelf, but also for the AR cube, which is really way smaller. So maybe let's use another example. The sideboard, if we use that at the same time, maybe we can see both models at the same time. Exactly, we can. There's the AR cube and the sideboard at the same time. All right. And then there is a third example page here that shows how to use the viewport component multiple times. So you could, there's no reason why you wouldn't use more than one viewport. So this example page shows actually 2 sessions with ShapeDiver models opened at the same time, and for each of the models, 2 different viewports. So you can imagine you could make one viewport, let's say a top view, the other one a perspective view, and so on, and then change parameters. The respective viewport actually updates, right? Okay, so now I think it's time to get started looking at the code. Unless there are some questions right now, so if you have some questions, please shout out. For example, did everyone who wanted to work on the example manage to clone the repository or download the zip file locally? And did everyone who actually wants to explore the code with us here and give it a try locally, were all of you able to get Visual Studio Code running? If not, please let us know.
Can we use just Visual Studio, or do we have to use code?
You can also use Visual Studio, should be fine. Any IDE that has good support for TypeScript is nice. So Visual Studio for sure works. Yeah, you might need to install certain Visual packages in Visual Studio. You know, in Visual Studio installer, you can install support for one or the other language, but in general, there shouldn't be a problem. It should work. Yeah. Yeah. So the steps in order to get started with the repository are these. Once you downloaded the code by cloning or downloading the zip file and unpacking it, in your IDE, you need to change to the directory that you unpacked. And then, as a very first step, please delete the file called package-log.json. Yeah? This file, I'm writing it to the chat. This file contains definition of which exact packages should get installed from where, and it has a slight problem in this repository, I noticed, so therefore just delete it, you don't need it. And then we need to follow the first setup step, which is also documented in the README of the repository, and that is run the command npm-i. So npm is a program called the Node Package Manager, and it's used for package management. It's like NuGet for C#, for example, right? When you run npm-i, what it does is it's looking at a file called package.json, which is contained in this repository, which defines all the packages this code here depends on, and then npm-i is going to install all of these dependencies. That's really important because otherwise the code is not going to work. So I would ask everyone who wants to get their hands dirty to run this command. And if there are errors popping up, the command is not succeeding, then let us know and hopefully we can help you. The output that you see here is quite normal. So there is NPM complains that there are some packages which with security vulnerabilities. Don't worry about it right now. The running npm-i might take a minute or two on your machine if you run it for the first time, because there's quite some packages to be resolved. And then the next thing we need to do in order to get the example running for local development is to actually run a command that's defined in here, start script. And we can run that by typing npm run start. So npm first npm and then second npm start. If we do that, if call npm run start, then what should happen is actually a local development web server is started in this directory, and your browser should be told to open this local address and show the example. So for whom isn't it working? Just let us know and we're gonna help you. If you have any super, just open your mic and tell us about the problem, or post a screenshot in the chat, and then we can help you.
Yeah, so it just says the npm is not recognized.
npm is not recognized, so then it means it's not installed, I guess. Did you are you working with Visual? No, you're working with Visual Studio, right?
I switched to code, so I got it in code.
Okay, so you need to install Node.js. Are you on Windows or on Mac?
Windows.
Windows, okay. Anyway, it shouldn't be a problem. You can install Node. I'm not sure what's the best way to install Node.js, but you guess.
Yeah, I downloaded it. Should be installed.
Okay, perfect. It should be installed. All right, but it tells you it doesn't find the command.
Mm-hmm.
Maybe so it means it doesn't have it in the path. There must be some problem with the installation, I guess. Because after you install Node, npm should be. Does it work if you type Node? Can you see something? For example, Node -- version.
No.
Okay. Maybe did you install Node after you installed Visual Studio Code, or before?
Yeah, maybe I restart.
Maybe you just have to restart Visual Studio Code such that the path is updated. Let's give that a try. Anyone else here having problems with getting the example running, or is everything working fine? If it's working fine, maybe you can put a thumbs up into the chat, so I know it's actually working for you.
I got an error said authentication token not provided.
If you do that, then please delete package log.json. You just delete the file, this file here, delete it, and then you run again npm-i.
Okay, thank you.
Super. And then And then please let me know whether it works.
It seems like it's working now. It just says, welcome to Node.
Okay, super. My colleague Dimitri just mentioned it might be that on Windows you have to restart the computer after installing Node, but I'm not sure. Could be. Okay,
Okay.
so for you now, Node is actually, when you type npm, does it show you, does it still say that the command is not found, or?
It says npm should be run outside of the Node JS REPL in your normal shell.
Ah, yeah. Aha, maybe you typed Node and maybe you're in here. Maybe you just have to exit Node.js. Let's give that a try.
Okay, it seems to be working now. Thanks.
Super. Perfect. Okay. Anyone else having problems, or is all good? It's too good to be true if this is working at the very beginning. I can't imagine that every one of you succeeds getting this up and running at the first try. So it's working. Okay, super. So any questions, any help needed to get the thing running, or are we fine? Okay. All right. So then if you have trouble getting it running, don't hesitate to unmute yourself and tell us about it, or write in the meeting chat. Otherwise, I'm now going to start showing you what's going on in that code, how that roughly works. Okay. So we are looking at the model, sorry, at the home page in our example. And as the very first step, we're gonna just give a try to the development mode here with the IDE and the browser. And it's gonna show you quite nicely how you can develop with React. So in our repository, we're gonna first look at the directory source. So in there is all the source code. By the way, there's a file called tickets.ts. So .ts stands for TypeScript, because all our code here is actually TypeScript. TypeScript, that's an extension to JavaScript, which provides typing information, which makes the whole development much more stable and convenient, because you can autocomplete and type checking and whatnot. Back to tickets.ts. So this file is like a configuration file. You can imagine it contains the tickets and model URLs I was talking about before when I showed the platform. So these are the API keys and API endpoints we need to access the example models. So you don't need to worry about them. You can plug in here your own model if you want, but you don't need to. You can just use them, use those models that are already defined here. Maybe a word before we start diving into the code about the dependencies of this example. The biggest dependency of the example is the user interface library that we are using. And this is called Maintain UI Kit. So there's a link to it in the README of the GitHub repo. Maintain, this is one of the most popular React component libraries that contains a lot of user interface components that are really convenient and very stable and very extremely configurable. So that means because we use that, you can make use of all of the features of this user interface library for your application, right? When you get started from our repository. As I said, the repository uses this user interface library, but it doesn't mean that the source code is completely useless if you want to use a different user interface library. Because if you're using React and a different user interface library, you can still copy all of the state management and hook code from our example and use it in your own web application that uses another user interface library. No problem about that. So the state management code and the hook code that we provide is completely independent of this user interface library. Just as an example, I'm going to show you the documentation of the app shell component. This is the component that we make use of So this app shell component provides basically a header bar, a sidebar, a main content window, and an optional side content window, which is not shown here. And we use exactly this component for our example pages, right? So this is the app shell, but there is no need for you, if you want to build a web application, to use this app shell. You can choose completely your own layout. It doesn't matter at all, right? It's just a nice place to get started, essentially. All right, going back to the source code. The entry point of the whole React application is index.tsx. .ts is the file ending for TypeScript, and X is actually for reactive component. So this is this file. It's basically a React component. It allows to write React code in here and TypeScript. The code that you see here, it looks a little bit like HTML and is motivated by HTML, of course, but it is not HTML, right? So it's actually reactive components that you see here. So actually, the index embeds more or less a single component, which is the app component. In Visual Studio Code, if I click the Option key, I can navigate around quite nicely, and here simply jump to app in app.tsx, which shows here basically the router. So this is, you won't need to touch that today. This defines which kind of routes exist, which kind of URL paths exist, and which pages to show for which URL path, right? So for example, if I type /view into the browser here, then I'm gonna, oh no, I don't, interestingly, it needs to be typed like this. Then I see the view page, yeah, and so on. All right, we're gonna begin with looking at the home page. Increasing my code font size. Yeah, let me see that I can do that. I'm not sure how it works in Visual Studio. Better like this? Super. All right. Maybe I can also do that here, actually. That's not that important here. Oops. So first, we're going to look at the home page just to give you an idea of how React code looks like. So this home page is a classic React functional component. So the home page that gets loaded when we show here, when we view here the home page, is actually a function that React executes when it's rendering that page for the first time. And that function returns React components, right? And these components that are used here, these are all components of the maintain user interface library. So if you want to find out what can be configured and what properties these components have, you can find that by looking into the maintain documentation. So for example, if we search for container here in the maintain documentation, we will find the documentation about container and what you can do with this. Yeah? So here's some containers. Container is just yeah, a container. For example, here we can see that there's a card component with a section and a group and a block quote and some text. And this actually corresponds to what we see here, this upper card. And now let's see how this local development mode works, because it's reactive as well, right? If I change the code here, then the development server that we started is going to detect the change, execute this function called homepage again, compare its output with the previous output, and then adapt the rendering of the page in the browser, right? So for example, if I change the heading here to ShapeDiver example, what a nice example, I can see the change showing up immediately in the browser. Let me know whether that works for you, and if not, cry out. This only works if you have started npm run start and if it's still running. When you stop npm run start, this is going to stop working. So basically, this gives you a very basic overview of how React is working, right? React is executing functions that return React components, and then it's comparing the output in terms of components. It's keeping this in a virtual document object model, in a virtual DOM that represents what you see on the web page. And it compares changes, and the changes it actually executes such that they are represented in the browser, right? And now you can already imagine how that will be useful to have a reactive user interface, because if our functions here output React components depending on variables in a different way, then React is going to compare the changes and make sure that whatever changed gets re-rendered, but the other stuff is going to stay the same, right? So there's no need, it doesn't re-render the whole page all the time, but only what changed. And it's very powerful because it's because you actually, as a developer, don't need to care about that. You only need to care that you structure your code in a nice way, such that there's not too much re-rendering necessary. But how that re-rendering works, you don't need to worry about. Typically. Jacob is not seeing the change. Is npm run start, is that still running for you? Maybe you can unmute yourself and then. Jacob?
It's running. Yeah, it's running.
Okay. And your local and your browser is directed to localhost 3000 or whatever it is on your end, right?
Yes.
Okay. So when you do changes in the code and save, it does not re-render.
Let me try. Okay, yeah, it worked.
Okay, super, perfect. It might take a little. In my development environment, it even detects changes before I save. But you can configure this somehow. I don't know exactly why, but I don't know exactly how. But it might take a few seconds to re-render. Right? Yeah.
Thank you.
Okay. So we could do bigger changes in here, right? For example, remove this block quote here, and we do that. It's gonna disappear. Whoops. Get it back again. This example, the homepage is not dynamic or reactive at all. This is just static components that get output and get rendered here. There's no logic that changes anything, right? Next, we're going to have a look at the model view page here. I'm opening it. And now I want to show you the corresponding React code, which is the page called view page. So this component is quite extensive and not super nicely structured, but it's okay. Let's scroll to the bottom of that page, which is where you will find the actual code, the actual React code that's returned by the component. And you can see here that it returns one parent component, which is called example page. And that example page is yet another component that we developed and put into this example here. So the example page is actually what uses the app shell that I've shown before. So the example page is basically a container for showing this app shell. So the example page actually has a header. This is the navigation, the menu on top with the logo. It has a navigation bar here on the side, and it has an aside component, which is basically what you see here on the side. And this aside component itself contains here a variable called aside. So actually the example page has a parameter called aside, where it takes other React components that it renders here, right? And then there is a main area. This is where we render the viewport here. So now you see this example page contains parameters that we can pass in, namely the main content and the side content. And that's what we make use of on all of our example pages. So the view page uses the example page with a viewport component as its main component. So this viewport component is what you see here in the middle, the main viewport. And it uses for aside, for the sidebar with the parameter controls, it here passes the variable parameter tabs, which is defined here. And we're going to look at this later in detail. But the principle is this. In all our example pages in this example, we use the example page component. There's always a main content, which is, for example, either one viewport or multiple viewports for the multiple viewport page. And then there's a sidebar which typically contains the parameter panels that we can see here. That's the whole gist of it. So the other sample pages, for example, the model select page, which you can see when we click select page here, uses the same principle. It's an example page. Then it uses a viewport component, again, here in the main content area. And it uses a component called model select on the sidebar. And you see model select is just another React component available here in the code that gets executed, and its output gets inserted here in the sidebar and rendered there, right? So I guess the gist of it is it's all functions that get executed and output React code, which gets assembled to a document object model, which gets then synchronized with what's shown in the browser. That's the whole principle of React. So there actually is never any HTML directly being generated. React calls the API of the browser to create the user interface elements. Are there any questions so far? Is someone struggling with the example setup, getting it working locally or so? Please let me know. All right. Seems very good. Okay, and I'm gonna switch back to the view page and open the view page here. And I'm now gonna start showing to you more details about these parameter panels here, right? How does this come to be? And we're gonna slowly work our way up in this view page .tsx file to understand what's going on. And then we will extend it a little by further code. So as we have seen, the sidebar here, parameter tabs, is in this case defined by this variable that defines tabs for the parameters and the exports, right? So this tabs component is again a component of Maintain. If we look at Maintain and search for tabs, we can find the documentation of the tabs component and how to use it and what we can adapt and so on, right? So it works by providing a list of tabs. This is for the header here. And then panels which show up below and which are visible or not depending on what you click on in the header, right? So here in this example, we have two panels corresponding headers. Here we can see the header called parameters. I change that to my parameters. It should show up here. You see exactly. Parameters has changed to my parameters. That's how I can influence that. And in the main panel, in the parameters panel, you can see that here we are using a component called parameters and exports accordion component. So that's one of the main components we provide, which actually provides the content that you see here. So if I, for example, just get rid of this component for a second, and you will see that in the parameters tab, there is simply no content anymore, right? The exports tab still has something, but the parameters tab doesn't have anything. So what does the what parameters does the parameters and exports accordion component actually take? This component has only a few parameters. One of them is called parameters, and it takes a definition of the parameters that the component should show. So the parameter of the accordion component, here we pass it a variable called parameter props, which we are going to get to a little bit later. And this is just an array of properties that defines the IDs of the parameter, basically, that should be shown, right? And there, the component has a second parameter called exports, as we can see here. Just reformatting the code a little so it's better readable. So this exports parameter, quite similar, takes an array of export properties which define which kind of export components should be shown in the user interface. So we can see here that because we can pass parameters and exports, we can actually mix parameters and export components in the user interface here, right? In the component on the first tab, we only show parameters actually. But in the component on the tab called exports, we are actually passing some parameters and we're also passing exports. And the accordion component mixes them into a single accordion, which can be very useful. So here we can actually see a group of exports and some parameters which actually influence how the exports get generated, right? So the exports, if I click them here, then the export gets triggered, for example, to download the file or send an email. And here I could change, for example, the line ending style that I want in my OBJ, or whether object names should be exported or not. Or if I send the email export, I could here change the email address to which I want the email sent to. Give it a try, enter your email address, then click send email, and you will receive an email containing a download link to the OBJ. All of these groups that we see here, they're actually simply a result of what the ShapeDiver backend API exposes, right? All of the parameters that we see here, they are parameters of the model we are looking at here, right? The nice thing about this example code is that the parameter accordion component actually doesn't really know that these parameters are corresponding to a ShapeDiver model. The parameter component just sees abstracted parameters and groups them together and visualizes them. And if I change parameter values, then it presents the user interface to accept or reject the changes and so on, execute the changes. So all of this is there's only user interface logic, but it's to a very high extent decoupled from what's going on in ShapeDiver. And that's really, really nice because it means, as you will see later, it's easy for you to add further, to make use of these components and add your own abstracted parameters that have some effect on the web application, but not necessarily affect the ShapeDiver model. So you will be able to define parameters here that do whatever, change visibility of other parameters, change the content of the scene, change the color of stuff in the scene, whatnot. All of this is possible. Maybe before we continue with the parameter panel, a few minutes about the viewport component that you see here. For example, this statistics bar here, you can easily switch that off because the viewport component contains a parameter called show statistics, which takes a Boolean and right now is set to true. If you set that to false, then the statistics is going to disappear. The viewport component itself, it takes an ID because we need to have a unique identifier for the viewport if you have more than one. It takes certain settings and branding. The branding is basically what you see when you load the page. You can define which logo you see here and so on. So, could change that. And then the viewport component also can take child components. And here in this page, we actually do have child components, which are those buttons that we see up there that allow us to do something with the viewport. If we remove this component here, then the buttons are going to be gone. I'm putting them back because they're actually useful, but you can, by changing parameters here, you can define which of the buttons show up, and you could add your own buttons to do whatnot. Maybe some words about the functionality of the buttons. There is a view in AR button, which provides really nice functionality because if you run this example on a desktop, like I am at right now, you click view in AR, and a modal dialog is going to show, and you will see a QR code that you can scan using your mobile device. And then you can view the contents of that scene in augmented reality on your phone. So we provide that functionality out of the box. It's really nice. By the way, if you open that page on mobile, you can do that. Then you're gonna directly jump to AR. So you cannot open your local development page easily on your phone, but what you can do is you can open the page. I'm going to send you the link in the chat. You can open the page in the chat on your phone, the deployed page. And then when you click the AR button, you can give it a try to look at one of the models in augmented reality. And obviously that works with any model you plug in here, right? There is another button, the zoom button, which if you click it once, it zooms to the extent of the scene, or if you click it twice, it zooms to the default camera position that was saved on the ShapeDiver platform. There's a full screen button where you can switch to full screen, and there's a button where you can switch between different cameras, photographic or perspective. These cameras can be defined in the ShapeDiver platform in the edit mode of the model. All right. So far about the viewport component. Now, are there any questions so far that you would like to answer? That you would like to have answered? Just let me know. All right. Let's have for a look at, so we get a question. Is there a support page if we encounter a bugging issue we can't fix? There is the following. You can ask if there is if the issue is specifically about the React example, then if you have a question right now, then I would ask you to ask it right now. If later on you have a question, the best is if you go to our forum, which you find links to on our platform, for example. You can find a link here to the help center or to the support forum. The support forum is actually a forum in McNeil's discourse where you can post your questions and you're going to answer them. Please be specific, as specific as possible when you post questions there. Actually, it's easy for us to understand the context and help you. All right. Let's go back to the page example code. And have a look at, again, at the parameter panel that we have seen here. Right? Here we've seen that these parameters and exports accordion component expects arguments that define which parameters and which exports to show. And now we're going to look at where these arguments are coming from. And in order to do that, we have to move up in the code a little. There is some commented code which we will make use of later. So for example, here we can see the definition of the parameter props variable, which is an array of parameter props. And it actually is created here by use of a so-called React hook. So all of the functions that whose name starts with hook, by convention, also all of the functions whose name starts with use, by convention, they are called hooks. And these hooks are functions that somehow hook into state of the application, right? So they hook into state, and that means if something on the state changes, then React is gonna know this and rerun your component function. And that's really powerful, right? So it means essentially our hook here gets some application state, which it makes use of to decide what kind of React components to return here. And if some other part of the application now changes state that influences what comes, that influences the output of this hook here, then React is going to know this if the state management is implemented properly. Re-execute this function here, potentially output different React components, and then your page is going to look different, right? That's how React essentially works, right? So I want to show you now how you can influence which kind of parameters of the ShapeDiver model show up here in the parameter panels. And the variable parameter props here hooks into state by, and it's here we specify a session ID. So that's an ID for the session with a ShapeDiver model. In this example, we have exactly one session, but we could have multiple ones. And it actually, as a second parameter here, there's a filter function. So if I remove that filter function for now, then this hook is going to return all of the parameters defined by the ShapeDiver model. So it means parameter props is going to contain all parameter definitions, and the component here is going to be rendered with all of the parameters. And that's why suddenly here in the parameter panel, we also see OBJ export options and email export options. So these are parameters that we also saw in the other tab, in the exports tab. No problem, we can have two user interfaces for the same parameter. That's completely fine. Just saying, and they are actually really reactive, right? So just as an example, if I change here the line ending style from line feed to, let me show you, it's line feed right now. In the second panel, it's also line feed, right? If I change that to caret return line feed and accept the change, it's also going to be caret return line feed here, where the parameter is rendered once again, right? So not saying it makes sense to show the same parameter twice, but you see the whole thing is really reactive, right? And properly state managed. All right, so the purpose of the filter function that was here in the first place was to not select all the parameters for rendering here on the first tab, but only some of them. And actually only the ones that are not related to exports of the model, right? So that's why this hook here that we provide as part of the example provides the possibility to specify a filter function. And this filter function is just a very small lambda expression. It takes a parameter definition, and then it returns a Boolean. And here it basically, let's just make this more simple so it's more easy to understand. Let's turn param, we map it to param.type equals float. So now we are selecting all the parameters that are floats, that are of type float. And this model only has a single parameter that is a float, a floating number. The board height parameter, all the other parameters they have a different type. That's why they are hidden. They're not shown here right now because we filtered them out, right? We could change the filter to show parameters of type float or parameters of type bool. And now we should see a second parameter, the Boolean toggle, which allows us to hide or show the doors. Perfect. So I guess you get the idea of how you can actually, using the components we provide here, create a user interface for your web application that's adaptive or reactive, right? Because this kind of filter function, of course, also could have parameters, right? Right now it's static, but we might filter these parameters here depending on some state of the application, right? For example, imagine you're coding configurator that consists of several steps. where you guide the user through steps, right? So the user interface might have a control panel, and then you let the user change settings and then move to the next control panel and so on. Right now, I'm going to revert the filter to what it was before. Which was return all parameters which do not have a group, which are not contained in a group, or whose group name does not include export, right? Because we want to not show all export related parameters here. And for the variable called export parameter props, we use the inverse filter. We actually filter all parameters whose group name does start with whose group name does include export. And if it does, it's going to be part of the export parameter props, which we pass here to the parameters argument of the accordion component, together with the exports. And that's why these exports and parameter components show both up here in this parameter panel. All right. Of course, we could also, let's make another example. Let's look at the model select page, where the sidebar is defined by model select. And here, what we see here is the content that's returned when we look at the model select page. So here, the model select page, as long as there is no selected model, you can see this multiple choice box and a hint below that. You can see it in the code here. It shows this multi-select component. Actually, this is rendered always. And then if selected model's length is 0, it shows this no models notification, which tells us select a model to see it in the viewport. That's what you can see here. As soon as there is at least one selected model, we actually show the tabs variable. And the tabs here is actually it's going to be rendered if and only if there's if there's at least one selected model, and then it's going to show a parameter tab for each model, right? So if we select the AR cube, it creates a tab whose name is going to be named by the model name, AR cube, and it shows the content of the panel. It shows the parameter accordion component with parameters and exports of the model. The model we're looking at doesn't have any exports, that's why we don't see any, we only see parameters. But if we pick another model, for example, this bookshelf, then there is actually geometry parameters which allow us to define the geometry of the model. Let's change something a little. And then there is also export components where we can download the 3D file or download the individual parts. So all of them in the same parameter accordion in this case. All right. One more thing I would like to show you before going on with the view page is we have put a lot of focus on making sure that this page works really well on mobile and other devices as well. So it has a really Jacob, I just saw your question. What did you mean by is the first one excludes?
Oh, yeah, in the view page example, just was curious, the comment, because both of them say whose group name includes.
Ah, yeah, sorry. It's wrong. The comment is wrong, yeah. It should be excludes, yeah. Yeah.
Appreciate it.
Yeah, thanks for the hint.
No problem.
We wanted to make sure that the whole page layout is reactive out of the box, so it's really useful, right? So you can notice that if you change the size of the page at some point, the navigation bar is going to disappear, and instead you will see a burger menu where you can show the navigation bar overlaying the main area. And then further, there's a breakpoint where the parameter tab moves to the bottom of the page. And this is essentially the layout you see on mobile, right? So on mobile, you can scroll your finger, then accept and reject changes. This accept and reject buttons always stay on top. All right. There is another way to do this in the browser. Maybe that's, yeah, actually that's the next thing to show. The browser developer tool. Some of you might know that, but it's important to show. Please note, my browser is a German language one, so the menu is gonna have different items, but essentially you will find an item called developer tools somewhere. And if you open those developer tools, you can decide to actually, typically I don't show them docked, I show them floating, but for this demonstration, it's better to actually show them docked. So I will keep them docked here. Just a little intro to the developer tools, because if you develop web applications, those are a must-have essentially. Essentially, the developer tools allow you to see the console output of the application. So an application can call console.log, console.debug, console.error to output messages here. For example, we do that, we output, in this example, debug messages. So if you search for console.debug in the code, you will find again and again messages like here, which then show up here in the console. For example, if I change a parameter, you can see here a message queuing change of parameter blah blah to 6. queue change of parameter, whatnot, to another value. And then I can see message if I accept the changes and so on. So that's the console. Then there's a possibility to inspect the whole document object model, which is very useful if you want to debug layout problems. For example, if you want to know why is that accordion or this button showing up here, you can just right-click it, say you want to inspect that, and then the developer tools will navigate to the corresponding user to the corresponding element in the document object tree, and vice versa. Right? You can influence the styling and whatnot. Also, what's good to know is the network tab shows you network communication that goes on. So here we can, for example, see what actually happens when we do a change that we execute. What is it that happens on the ShapeDiver API? If I reload the page completely, which I'm going to do now, there's a lot of network requests. Well, actually, it's not that many. Quite some. And I'm going to filter the ones that are interesting in terms of ShapeDiver right now. I can do that. I type in ticket here. So that's the request. The first request, which actually the ShapeDiver viewer embedded into this application here, sends to open a session with the ShapeDiver model we are seeing here. So this request includes the ticket in its URL, and the response. You can see the response here. That's interesting to see because here you can, for example, see the API, what's actually going on the API, for example, and how parameters are defined. So the response to this session init request returns a definition of the parameters of the model, the outputs of the model, the exports of the model, and so on. For example, here we can see each parameter we can see as an ID, as an optional, as a name, a type. For example, this parameter is a file parameter. It's the one we can see here at the bottom, where we could choose a different image. The next one here is a text input. Let's look for the slider. Here we have the float parameter that we were filtering before. So it's a float parameter. The name is board height. That's this one. Its default value is 0. It's a float with 3 digits after the comma. And the maximum value is 1. The minimum value is -1. And this parameter is contained in a group called geometry. By the way, these groups here, the way the parameters are grouped, this is you can define that in the Grasshopper model. It's essentially works like this. You just create a group in Grasshopper which contains your components, and you can name those groups, and this is exactly the group definition that shows up on the API. Of course, in your web application, you can also decide to disregard this information and overwrite it, but by default, that's how the components are grouped. All right. This is how parameters are defined on the API. There's also a definition of the exports. again, this is an object, which, for example, defines the OBJ export that we have seen here before. This export is of type download. This image export is also of type download, and then we have another export which is of type email. And the model also defines outputs, and the outputs are the things, typically the things you are seeing in the viewport. So, for example, there is an output called shelf, which contains the geometry of the shelf itself. And the geometry is actually not embedded directly into this API response. It's just a link to a geometric asset to download and display. So among network requests here, you will also find one that actually downloads this GLTF, for example, here. Yeah, this is a download of the geometric asset of the so-called GLTF asset that contains the geometry to be displayed here. Of course, when you run an export, it could be any type of file format that is supported by Rhino and further formats, because our plugin contains functionality to export PDFs, images, all kinds of like IFC. You could export IFC text files and so on. No limits. All right. That was a rough detour to what's going on in the API, the developer tools for web development. Now, next, let's check out in a little more detail of where those parameters are actually coming from in the first place that we are using here, right? We have seen how we can define a parameter panel component and change its contents by changing the filter function here. The view page here defines which model it should show, and opens actually a session with that model. So we've seen before this file called tickets, where I defined, I copy-pasted API keys that you can use. Of course, you can put your own ones in here. And here we are from that example model data structure, we are selecting the sideboard example. Of course, we could change to any other, right? We could here change it to the R cube example, and then that page is going to re-render and show the R cube with its parameters. There are no exports for this model. That's why this spinner doesn't stop showing. So how does all of this work? Here we define, we use a hook called use session, which we provide as part of this example. And the use session hook takes a data structure, just an object that defines essentially the API key and the API endpoint of the model to load, right? To open a session with. So here we define a ticket, the model URL. We have to also provide an ID, which is just some namespace. It's just a name that you assign to this session with the model, because you could open multiple sessions with the same or different models at once, and all of them need to have a unique ID, but you can choose it completely freely. The use session hook here, you can inspect the source code if you want by clicking here. is a hook that we provide, and the hook is quite intricate, to be honest. So it's not so easy to understand probably, but in general, what's going on here is it creates, makes a call to the ShapeDiver viewer to create a session with the model. It waits for this to be ready, and then it registers the parameters that are defined by this model with the state management of the web application. So first, it creates a session with the model. Then it knows about all the parameters that are defined by the model. And then it puts into the state of the application the definition of the user interface components, essentially, right? That should be shown. And it's state management. So that's what this hook does. Right? It opens a session and in the state of the application defines what are the parameters of the model and the exports. But that's about it. It only defines this. And then, because this thing is reactive, as soon as the use session hook is done in the background with loading, with opening the session and defining the parameters, then React knows, aha, now I need to re-render this component because the information coming out of use session has changed, right? All right, so the component is going to be re-rendered, and now the hook here, which returns parameters based on session ID or exports based on session ID, they are suddenly going to return export and parameter definitions, right? Before they didn't, because there was no parameters defined yet. But once the session is established, those hooks are going to actually return parameters. And then because of that, the accordion component changes its output to actually have parameter and export components. And then the page re-renders and shows the parameter component, right? When we reload the page, in the beginning, there is no parameters and export. Right? Only once the session is established, does the page re-render. That's the magic of React. All right. Maybe before we go on, I'm going to show you one more thing in the developer tools, which is quite interesting. If you are going to dive deeper into the components here, no, I'm going to first show you actually parameter components. Sorry. In source components ShapeDiver parameter, you will find components that actually define the sliders and put in checkboxes and whatnot, right? Let's take a look at a simple example, a string component. It looks really, really simple, right? Essentially what it does is it takes certain properties. Essentially, these properties are the parameter ID and the session ID of the parameter. And it also takes two other properties which define the behavior of the component, namely if the component should get disabled if the value is dirty, so if it has been changed. And it also has a property called accept reject mode, which allows us to define the behavior of the component. I will show you in a minute. So, so here it actually returns two elements, two components of the maintain user interface library. So the the parameter label component is actually a further component that outputs a group and a text. So this is the maintain user interface library. If we actually type some code in here, then all of the parameter labels suddenly gonna have XXX. Can you see it? Nice how this works without rendering the whole page. And the string component then also uses a text input. This is, for example, do you have an example here? Yeah, here. This position parameter is actually text input, right? So this is actually a component of the Mentine user interface library. You could search for it here, and you find the properties of the text input and how you can change that. And that already tells you that the dependency to the Mentine user interface library isn't that strong, because most of the logic does not depend at all to Mentine, right? So if you would want to swap out the user interface library, there's not much work to do, essentially. It's swapping out which components get returned here. But in other user interface libraries, you will find similar components, and the difficult part, which is the state management, is all solved and can be used with any other user interface library. Maybe a glimpse of what's going on in this state management in the background. We're going to switch to the developer tools again. Make it a bit bigger. And when you are developing with React, it's very useful to install the React developer tools. So you can find developer tools that allow you to inspect the component graph. So that's not exactly the DOM that you see elements, but close. But here you can really see, for example, yeah, here you see the view page component, which uses an example page component, which uses an app shelf of Mentine, which it does a lot of stuff in between the header, the navigation bar, the sidebar. Really nice to see how this is working here. So you can nicely explore the React components here and see, and more super nice. You can also see the property values, right? Where are our accordion components? Here. There's the parameter accordion component. Super. Here we can actually see the parameters that have been passed. That's perfect. Right? You see that the parameter accordion component, when it was rendered, we got the parameters of this component. The value can be seen here. So the session ID and the parameter ID. And this data is used further down by the actual slider components and so on. Yeah, here we can see the parameter Boolean component, for example. Parameter Boolean component takes parameters session ID, parameter ID, disable if dirty, accept reject mode. And the Boolean component has a label, right? Label. There's a switch. That's it. And you can see the hooks it uses. Super useful. All right, that's the component explorer. The profiler I never used myself actually, but it would be good to do. But what's really important also to know is the state management. If you install the Redux tools, you can select here from this application state stores that are available. So the application here registers a few of them. One is the ShapeDiver Viewer store, which has functions like close viewport, open viewport, close viewport, create viewport. And then there's a store for the parameter definitions. So whenever we open a session, then we actually add parameter definitions of the session to the store. So here you can see that the parameter stores, for example, contain parameters for a session called session 1. And here they're removed again, and so on. And then there's individual stores for the parameter values. For example, we can see state changes when the user interface value changes, how the state changes from dirty false to dirty true, and therefore disables the component, and so on. All right. I want to show you now the two different modes in which we can actually use the parameter panel. Right now, when we change parameter values here, the changes are not executed immediately, right? But they are queued. And as soon as I click accept, changes are executed. So that's useful if in your application you want to make sure the user doesn't do too many changes and doesn't trigger too many computations, right? Which might be resource intensive. It might be that your model computes 10 seconds, 15 seconds, whatever. But there's also a way to run that parameter panel in a different mode, which does not have this acceptance or rejecting of parameter changes. And using the code we provide here, it's very simple to do that. So if we go back to the view page, when we register a session, we can specify whether we want the parameters to be in accept reject mode or in immediate execution mode. So here the accept reject mode is switched on, but if I switch that off, the page is going to be rendered, and now we don't have any accept reject buttons anymore. So every change I do is going to be executed immediately. You see, during the execution, all of the parameters are actually disabled. Sweet. But there is no queuing of changes. The nice thing is the parameter panel allows to mix that behavior. So in a single accordion, you can have parameters that require committing of changes and others that do not require committing of changes. We're gonna get to that pretty soon. So for now, I'm gonna revert this behavior to accept reject mode. So we're back again in the behavior where we're actually individually accepting or rejecting changes. You know, this model is actually pretty nice, I have to show you, because you can also import an OBJ file instead of using these cubes here, and then the image is going to be projected onto this mesh. Let's see where that works. Yes. So we can see the ShapeDiver logo projected to the bench. Of course, you can do that using your own OBJ image. You can change the image here, just as a side note. I'm not doing it anymore. Okay, this is particularly nice for augmented reality, actually. All right, so before we go on, and I will show you how you can add custom parameter controls here to your application and do things independently of your ShapeDiver model. I'm going to take a short break to refresh my voice, drink a little bit, and I will be back in latest 10 minutes. All right, for the last hour. Thank you, see you soon. And we're going to start again by answering questions if you have any. All right, be back in a few minutes. All right, back again. Did any questions come up? Any problems to solve? Please shout out. Okay. Okay, then we are going to continue a bit defining custom parameters, and then we'll call it a masterclass. So in the few page example, we have also included some sample code on how you can define custom components in the parameters panel. That's really useful. And in order to do that, I'm going to just uncomment this code here. And let's see what happens here. So here, you're using a hook called use define shared parameters that we provide. And this hook takes 4 parameters. One is a session ID, so that's just a namespace for your manually defined parameters. Those parameters now do not depend on a ShapeDiver model, right? They are just defined here in your application, and you can do whatever you want with them. So they live in a namespace. Of course, you can call this hook several times if you want to define lots of parameters. The second parameter defines whether this parameter shall run in the accept reject mode or just execute immediately. Then the third parameter takes a single or an array of parameter definitions And the data scheme that you have to provide here is exactly the same that is coming across the API from ShapeDiver. So here you're actually defining a parameter called, whose name is custom color, whose ID is myParam, whose type is color, and has some default value. And then the fourth parameter here is actually an executor function. So that function is gonna get called as soon as changes to your parameter should get executed. That means it's gonna get called immediately if the parameter is not running in accept reject mode, or it's gonna be get called as soon as the user clicks the accept button if the parameter is running in accept reject mode, right? All right. And we can see here, yeah, in the executor, let's for now just ignore what's there and add a console log statement where we log the values that the executor is called with, and then we can see it in the browser console. So our new parameters already show up here in my parameters. This group is called my parameters because down here we define a default group name of these parameters to be my parameters. Instead, we could also define the group here by defining the group property, which takes an ID, my group, and params, and it's gonna show up with my params. But let's remove it again and stick with the thing we had before. All right, so now if we are gonna change values of this color parameter, remember we defined the parameter to use immediate execution, and that's why in the browser console we can see immediate changes of the parameter. Right, so the console log statements shows the objects we get called with, and it's actually the ID of the parameter, my param, and the value. Now we could add a second parameter. I'm copying this object, call it my param2. We make it and opacity, give it a value of 0.5, define the minimum to be 0, the maximum to be 1, the type to be float, and the number of decimals to be 2. Now, get this slider here. Opacity takes values between 0 and 1, and our executor gets called the way we want it. Please note, this case already shows a mixture between parameters that have to be committed, accepted or rejected, and parameters that don't need to, right? The custom ones we defined they don't take part in the acceptance right now. They get executed immediately. We could change that, but right now it's like so. We could change that by here switching that value. If you do so, then the values need to be accepted or rejected. All right, let's go back to immediate changes. Now, here in this handler function, we're actually if the change object contains a value for the myParam parameter, then we are calling a setter function, which is defined up here by calling the use state hook of React. This is the most commonly used hook in React that defines a reactive variable and then corresponding setter function. So the reactive variable is material properties, and the setter function is set material properties. So we must not change material properties directly. We have to call the setter because otherwise it's not reactive anymore. And here we are calling set material properties with the value with actually to set the material properties with the color value that we got from the color parameter. And these material properties, this is an object defined in the ShapeDiver viewer. So this allows you to influence material. You see there's a lot of stuff that you can change here. For now, we're just changing this super easy stuff. Color and opacity. We're gonna change opacity. Or maybe metalness. No, let's stick with opacity. Yeah. So here this change for color is implemented. Now we are going to copy this and also change opacity. Sorry, if my param 2 is in values, we set the opacity. Actually, it's stupid that we call this my param 2. Let's just rename the ID of the params according to the meaning. So we call color. It's a bit easier to. Oops. Right. So we can change these material properties. What we cannot do, but it doesn't have an effect yet, right? And in order to do that, we can change here we can start using the use node material hook, which takes a node in the C tree and these materials, with these material properties, which we're updating, and applies these material properties to the output node. And this output node actually is the result of the call to another hook up here, which is called use output, which is called using a session ID and an output name and returns a node. So let us give it a try. And if you use that, you might be lucky. And let's see what the color changes actually. It does not. Node is undefined. Yeah, that's because, okay. Yeah, the name of the output for this model, we have to put the correct name here. So in this code example, it says shelf, which is the name of an output for the shelf example model. I'm going to use ShapeDiver display here because this is the name of the output in this model actually. You can see that in Grasshopper in our model here, the display component is actually called ShapeDiver display. And that's why we have to pass the proper name on the other side. All right, so now if we change, yes, you can see it already works. We got the color. My computer is really slow right now, probably due to Zoom. But you can see the changes are already taking place. And if I change opacity here, it's actually changes opacity of the model. Yeah, and it looks pretty nice. Cool. And get your logo faded away. Sweet. All right. So that's how we can define custom parameter components and hook them up with our application logic. All right. Jacob is getting an error. What kind of error are you getting? Just show.
With that, it says for the second definition for opacity, it's saying expected 4 arguments but got 5.
Ah, there must be some. Probably you have entered a comma too much somewhere here. Could it be?
Oh, I see. Wait, there needs to be another if statement.
Yeah. Is it working?
I didn't change that if statement there, so I can just copy this.
Yeah, okay, yeah. Super. But in general, it's working for you, right? That's cool.
It didn't work yet, but
okay.
Yeah, it's still. Oh, I see. Yeah, still getting an issue, but
it's not working yet.
Not yet.
Okay. You wanna copy a screenshot into the chat or?
Okay. Sure.
Sure, let's just do it. Yeah.
Okay.
Something is wrong with this color. Not really. This is strange. All right. Are you sharing a screenshot, Jacob?
Yeah. I'm sending it right now.
Okay, super. Here's a fog. Super. I can see the screen.
There's a second one in there too.
Okay. I think I've seen it. You know what? The problem is here. This needs to be an array instead of an object. Can you see my cursor?
Mm-hmm.
This is a square bracket here, and this one as well. And you use the curly bracket here.
Okay, I see.
Yeah. So because the square bracket is basically for an array, right? So we pass an array of parameter definitions here. That's where the syntax error happened. So if you change that to array,
Okay.
it should be fixed. Or that's the next step. Let's give it a try.
Trying it. Thanks.
Sure, you're welcome. So just quickly fixing a bug that I noticed because the default color that I specified doesn't show up. So, and that's because of this conversion function here. So I'll try to fix the problem right now. Let me see where I succeed. Should do this in live development mode. It's really slow if it tries to reload all the time. And let's see whether we manage to fix that problem. I'm not too sure about that. Yes, perfect. So now the color is initialized properly. So I'm gonna commit this fix right away. And let's just do some testing beforehand. Actually, the changes are not applied to the scene if you haven't done at least one parameter change, and that's a bug that still have to fix, but that's not something for today. Of course, we keep maintaining this repository and extend it further, and we receive feedback. So if you run into issues using the repository, you can either issue issues on GitHub or ask us in our forum, or in the next week or so, or next week's this Slack channel of AECtech will also still be available, so we can use that. Just quickly. Commit this fix that I just implemented. Right, perfect. Jacob, it doesn't change colors or opacity. That's exactly the problem I just mentioned, I think. Just go ahead and do a single, whatever you want, change one of the parameters that update the scene tree once. And once you did that, the changes should get applied.
Say again? Oh, it's like an accept reject.
Exactly. Just do it once, and then the color and opacity changes should get applied. But there is a bug which I still have to fix, which doesn't apply the changes if you haven't updated the geometry at least once after loading it. Right? So you can change any of the geometry parameters except the change, and then it should work actually. As you can see, there's still a problem because only the opacity got applied now, not the color, and that's due to how we implemented this here, which is not correct. Actually, we have to. The problem that happens here is this: if we call set material properties, here we pass color, but if before we change the opacity, we're gonna override the opacity value. So what we actually have to do is we have to pass in the current value, and we do that using this deconstruction operator. And that should fix the problem. Let's check whether it works as expected. So, might change the geometry a little bit. There still seems to be an issue. Yeah, there certainly is an issue. Weird. Now let's try once again. Not working as expected. Okay. Initial values. Yeah. Let's see. No, doesn't work. This is weird. I'm doing something wrong here. It's not totally clear to me what I'm doing wrong. Mm-hmm. No, it's weird. Yeah, I have to debug that after the call. Something's not exactly working the way I wanted. All right, Jacob, is it working for you now?
It's still not.
So it's still not working at all, or
there's no errors, but I'm still not getting the colors or opacity to change.
okay? Are you using this model or another one actually?
This one.
Okay. Up here, did you change the output name to this GLTF display?
The GLTF.
Oh, I will copy paste it for you. So this is actually the name that is defined, the name of the output of this model that we want to change.
Thank you. All
right.
They'll do the geometry change too?
Yeah, the geometry change you have to do initially.
Okay, it works now. Thanks.
Ah, super. Okay, it's still not great because there's some problem. It doesn't apply both changes, and I'm not sure yet what I'm doing wrong. But yeah, I will have to figure it out another time. Yeah. All right. I'm not sure if you have any other active participants because there's so little feedback. Jacob, is there something that comes to your mind that you want to know or ask or so?
Yeah, thanks for asking. I don't have anything immediate on the technical side. I was curious about use cases, but we could also wait on that if there's more things to cover.
I think it's fine. Let's talk about use cases because I roughly covered what I wanted to cover, right? I mean, it doesn't make so much sense to go into further detail about React because it's just an extensive subject. But if you want to talk about use cases, let's do that. Yeah, sure. What's actually your? I forgot. You are working for.
I'm at SOM in New York.
SOM. All right. Mm-hmm.
And so yeah, I was just wondering if what would you say is the main, or maybe if there's more than what were some of the main use cases for architects specifically? What do you see them building with this?
Basically, for architects, we see building configurators to be shared with the team or externally, right? So recently, for example, let me see whether I can find that post. There was a very nice use case being shared by, what's it called, Cactus? Yeah, exactly this one, Yates. They developed an application for in-house carbon modeling. I will share the link to the post to the notes. So this would be an example of what you can do. Actually, this example was developed without that React template. A developer there did it from scratch, but he I had to spend quite some time. So using the example code that we provide in the meanwhile, it's going to be much easier. So what they are doing here is basically they have some rough guess of carbon modeling, right? Design tool, and it's implemented using ShapeDiver. Right? So the Grasshopper model runs on ShapeDiver, the calculations, and made available as a web online tool. So that would be a use case that comes to my mind, right?
So for sort of like client-facing
as well, right? Yeah. So if you have client-facing use cases, in some cases it might be sufficient to use the iframe feature that we offer. Then you don't need to have a custom user interface. You can just embed our iframe. Or if it shouldn't be shared as an iframe, there's always the option to actually privately share on the ShapeDiver platform, right? So if you have two, if you want to share with another registered user, you can actually on the platform share privately with a specific user, and then only that user can view the model. And because if you actually have an iframe, then of course it can only be accessed if you know the URL, but it's not completely protected, right? So it depends on the requirements of the project. Sorry, yeah, we thought you raised your hand, right?
Oh no, I think I had a similar, kind of question related to use case. I know of architects and engineers using this platform to download, export Revit files, or obviously, 2D drawings or so forth. Some of us went through the previous session where we looked at exporting Illustrator, right?
Yeah. Mm-hmm.
Is my understanding that all of that is still generated in the Grasshopper script, and then that's just a format that comes out, just like we saw on an object file here.
Exactly. Yes.
Okay.
So I can show you these export components in the other Grasshopper model here.
So there's really nothing special about the development code then related to that. Okay.
Well, for example, here this model is the sideboard that we presented before, right? You don't see the materials here, but they're there. But here this thing has exports. Let me show where they are. Here. So essentially, this is the thing that defines the export. That's all you need to do, right? So there's a component that takes data. It takes export options and a name, a file name, and that's it. And then this component here, in this case, it's called image export. So that's exactly the one that shows up on the API as image export, right? Mm-hmm. If you define another parameter, if you copy that component, then that's it. Essentially, that's what you need to do. And that works with all export formats that are available in Rhino, essentially, right? So where are the export components that are here? So here we have all file formats that you can use with Rhino, right? But then there's also the possibility to create PDFs. So we have the possibility to create parametric PDFs and images. And that's used for all kinds of drawings and so. And we support plugins like Geometry Gym to make IFC. And
then all the Rhino inside Revit components will eventually make.
The Rhino inside Revit won't run in the cloud, right? But if you you can plug ShapeDiver also directly inside Grasshopper. So there is components available here. Where are they here? Client plugin, where you can actually run a computation of a ShapeDiver model from within Grasshopper and get the outputs here in Grasshopper.
So different topic than not necessarily web development like we're talking today. Okay.
Exactly, but you can do that, and then that way you can plug it into Revit or whatever.
Okay.
Yeah.
Okay. Thank you.
I'm not sure whether in the other workshop our recent integrations were mentioned. Maybe not. We are working heavily on actually getting the integration with Spectral working. So then it's going to be possible to trigger ShapeDiver computations from a Spectral webhook, for example. Right? So if you push something to a Spectral stream, then you can trigger an automatic computation and it goes back to the stream. That's one option.
That's pretty cool.
Or what we did recently is an integration with Victor. That might be worth mentioning. It's this platform called Victor AI, where you can code engineering applications using Python, right? Let me see where these examples are. We deployed recently also a GitHub repository that you can fork from. Oops. That includes 2 sample applications of a Victor app that integrates ShapeDiver. So here you can see that app. So in this case, essentially, the viewport here shows is actually the WebGL is the viewer of Victor, but it shows geometry that's coming out of the ShapeDiver model, right? And you get your parameter panel here and can change parameters, and then the thing recomputes. And it's really nice because you can also have the image and the PDF export directly embedded in the app here, right? So that allows to make very powerful web applications as well. If you don't, let's say if the user interface doesn't need to be super polished and nice, and it's just about it's about engineering and getting a tool done, then this way of integration is probably the fastest you can get. Because then you can use Python code to quickly prototype the interface. That's really simple with Victor, and plug a Grasshopper model running on ShapeDiver. All right. Yeah. Okay. You have any further questions? Are one of you going to be at the hackathon next week, actually?
That was too far for me. Thanks, though.
Yeah, okay. I will be there again. Let's see. Okay.
Yeah, I was hoping to, but I think I have a conflict, unfortunately.
All right. Yeah.
This was a nice option. Thank you to have the virtual.
Thank you so much. Yeah, that was very good.
Cool. Yeah. So let me know if you have any further questions. Otherwise, I would close the session slowly because it's getting late for me. I did the second one, and it's I'm based in Europe, right? So it's 6 hours further.
Right. Just one quick follow-up. Sorry, about
Sure.
the use cases. If you have another second.
Sure.
Just I appreciate it. But have you spoken to anyone that in AEC that have sort of integrated this process and then said, like, this is actually allowing us to, let's say, charge clients more because it's an additional service? I mean, that's partly like on, our side, for business development, like we would have to do that, but just any feedback would be helpful to understand like what that willingness to pay is.
So on the topic of charging more, I don't know actually whether some, but we have several clients in AEC that use it for internal and external workflows. So whether it's passed on to the customers, I can't say. I don't know that exactly. Yeah.
All right, appreciate it.
Yeah, sure. Yeah. So in general for AEC we offer maybe a few words about the account types, right? So in ShapeDiver you when you register there's a few options of plans that you have essentially. So the first one, designer allows iframe embedding only, right? So it's just the iframe and no direct embedding like we did it today. From Designer Plus, you can use the direct embedding in the web application. And then there's the business plan where you can also access it from backend applications. All of these come with a standard set of plugins deployed, right? And it's actually quite an extensive set of plugins. You can actually see all of these plugins that are available when in your account. There's a backend tab where you will be able to see the precise plugins and their versions that are deployed to that backend system. So we keep this list up to date, but it's not always the latest versions of the plugins, right? If a client has a need to have a special plugin, for example, a plugin which they privately develop, then there is the possibility to have a dedicated ShapeDiver system, which basically is a ShapeDiver backend that's just running for that enterprise client, and then you can deploy any plugin you want, right? It just has a higher cost because we run a dedicated ShapeDiver system for you. We do that for several bigger companies, so it's not something that is crazy in terms of pricing, but it's more expensive than the other plans, right? Yeah. But then you really have the freedom to have your own plugin deployed to the system.
What is your preferred, or what is the most successful balance between an external developer team and your development team on the website?
So the services we offer, we have a team that does projects and project work, right? So what we offer is actually the Grasshopper modeling plus consultancy on how to tune the Grasshopper models to make them really fast and actually use the plugins in an optimum way, such that the computations are as fast as possible. And we don't directly offer the front-end web development, but we have several partners, agencies who do that, right? And who know how to use our product. And it's getting easier and easier to get started using, for example, the code I was presenting today, because really any web developer, any reasonable web developer nowadays should know how to use React, and then it's much easier for them to get started with the code we provide here, right?
That's helpful. Thank you. Yeah, makes sense.
And of course, then we are available to do consultancy, right? Basically, talk to the web developer what they have to take care of and coordinate between the Grasshopper part and the web development part. Yeah. Mm-hmm. It's important to handle this good because really good web developers don't know Grasshopper, and really good Grasshopper developers don't know web development.
Very true.
Yeah, but it's we make it as easy as possible to marry the two worlds, right? Yeah,
it's exciting. Thank you.
All right. Super. So then, you have further questions? All right. And well, thanks for joining. Thanks for your attention. if you have any questions, you can reach me directly, for example, via LinkedIn. You know my email. In the next days, this shared Slack channel still is open. Otherwise, you can use our forum. So there should be lots of possibilities to get in touch with us. All right. Well, thank you. And next week, maybe I can see some of you at the hackathon. All right.
You enjoy.
Thank you. Have a good evening. Bye-bye.
Bye.
Bye.
Thank you.
Bye-bye.